Good morning, guys. This is Teacher Patrick, and I'm gonna go back to yesterday's topic on capacitance. You guys indicated that you wanted some explanation, and I just quickly want to go through it. We're going to specifically look at skills for capacitors, calculating the circuits. Okay, so if you bear with me, this is yesterday's question. They had two 48 ohm farad, 48 farad capacitors in parallel and 148 microfarad um, capacitor in series, and we have 2 points AB. Okay, now guys, what I did yesterday when I was without thought, I went back to my RVI circuit. I went to this mentality. Okay, so the first thing that we need to remember is that when we're working with circuits and capacitors specifically, we want to forget about current. We want to think in terms of charge. Okay, so the moment you start thinking about current, you can get confused. Simplify the circuit, just think of the relationship V as Q over C, and we have those three values. Okay, now if we look at it, okay, they asked us to get the equivalent resistance 48 and 48, okay, to get the total of the parallel. In parallel we add them simply together, so 48 plus 48 is 96, and if we have another 48 and a 96, it's going to be 1 over 48 plus 1 over 96 inverted. It's going to give us 3 over 96, or 96 over 3 when we invert that, and that's going to give us 32 microfarad. So we know that we've got 32 microfarad. Okay, so the question was that the maximum safe voltage for each of them is, or the maximum safe voltage for each of them is 6 volts. So what is the maximum voltage between B and C to get that? Now, what we need to remember, guys, we now know that we add the capacitance in parallel. But what happens to the charge? Okay, so if we want the maximum voltage over each, okay, so even if you look at number 3, this one here, we want this one to have 6, okay, and now if in terms of, I just want to calculate a value for the charge here, because we know the charge in parallel series will be the same, but the charge is separated. So let's get the total charge here, and then we'll work with that. Okay, so remember this is in series, and that is in parallel. Capacitance adds in parallel, and it adds inversely in series. Voltage splits up in series, but is equal in parallel, and the charge is equal in series, but splits up in parallel. So if we can get the charge here, we know what is the split between those two. Obviously, it's going to be half-half. But so if we use this, we say that Q is VC. We have our 48 times 6, or 6 times 48. Okay, that gives us 6 less than 300, so it's 294 microcoulombs. Okay, so this is 294 microcoulombs. Okay, in series we've got 294. Okay, in parallel that 294 splits, can split equally, so 294 divided by 2 is going to give us 147 and 147 microcoulombs. Okay, now here comes the thing. Why did we just simply say we halve the voltage there? If we look at our total, so in parallel, if we look at this one, we still have the 294 for the whole thing, but now we've got double the capacitance. Okay, So 294 divided by, if we do the same calculation we did over here, well, if we do the other way, if we want to calculate this voltage, we're going to see that we have 294 divided by 96, okay, and that's going to give us 3. So we have 3 volts here, but the voltage is the same everywhere. Okay, so what's the total voltage? Okay, in parallel the voltage is equal, but in series we add the voltage, so we get a safe equivalent voltage of 9. Okay, so what is the thinking pattern? Don't just think in terms of the voltage directly. We want to think in terms of the charge. We could calculate the charge here. If we want to calculate, we know this is 6 volts. We have that. We can calculate the charge, but what we could have seen is that if I've got twice the capacitance with the same charge, okay, then my voltage needs to be halved. So if we think about this one again, okay, if I've got twice the capacitance, okay, the charge stays the same, what's going to happen to my voltage? My voltage is going to be halved. And therefore, the parallel section has 3. We know that each of them has 3, so that's 3 volts, which adds up to 3. This is 6 volts, and 3 and 6 becomes 9 volts. I hope that helps. Please let me know